yourself for us to hear the sound.
Okay, we will start the presentation since the running short of time since we are.
I've typed my video, my email in the chat. So if it's okay, you could also send us the video at the same time. So if any technical problems happen later, we can also project this videos for you.
Okay.
And yes, thank you very much.
Now,
And then I will have like 1 minute very quickly to go through some housekeeping notes, and I will give you the floor.
Yeah, sure.
Sure. Thank you very much. So welcome everyone to this event. This is one of our COP5 online events, and all our COP5 events holding this week are an informal platform for parties and observers to share information and bring knowledge to address in technology, research, and policy to the attention of parties and to the global community that the convention serves. Here, we embrace informally as an opportunity to innovation and collaboration, bring together a spectrum of stakeholders to explore fresh alternatives and solutions. And all your participations are really highly appreciated. And there are some quick housekeeping notes that we can go through. So previously, we already go through how participants could raise your hands and join the Q&A section at the end of this event. But also, if you encounter any questions or you have any thoughts you want to share with us, you're more than welcome to type it in the chat box and share it with us. And also, please kindly note that this session is going to be recorded and broadcast live on YouTube. Please help us to keep improving the experience by filling out a survey at the end of this webinar. And without further ado, I will give the floor to Mr. Nadika. Thank you very much.
Thank you very much. Good morning, good afternoon, and good evening, dear friends, colleagues, and officers. My name is Mahinda Verahara. Just to moderate of this event, just to give an introduction about the Minamata Convention and Sri Lanka. We signed the convention in 2014 and ratified the convention in 2017. Thank you for Minamata Secretariat and UNIDO, and we were able to get a Minamata initial assessment project from Jeff funding, and then in the project in the first phase we have made the inventory, and we found that its small scale jewelry sector is I mean, it's a sound sector that we have to analyze as a country, so that we have given that contract to Gem and Jewelry Research and Training Institute in Sri Lanka, and Ms. Nadika Mantri Ratna, on behalf of Gem and Jewelry Research and Training Center, now will display the work they have completed through a presentation, and second, she will play a video where you can see what we have done as a country. Thank you very much for UNIDO. Thank you very much for Minamata Secretariat, especially Mr. Richard and Shreya Full for your assistance and mediation in giving us the opportunity to have this event. Thank you very much.
Good evening, all of you. I'm Nadika Mantriratne from Gem and Jewellery Research and Training Institute in Sri Lanka. I'm here to present Mercury usage in small-scale jewellery manufacturing sector in Sri Lanka and Can you hear me?
Yes, we can confirm that we can hear you clearly. Thank you very much.
I'm here to present Mercury usage in small-scale jewellery manufacturing sector in Sri Lanka and introducing non-mercury environmental friendly alternative for waste gold separation. Uh, this project was conducted by Ministry of Environment in Sri Lanka in collaboration with Gem and Jewellery Research and Training Institute, funded by Global Environmental Facility. When moved to the introduction, we all know in April 1995, two sisters who lived in Minamata Bay in Japan were hospitalized due to the difficulties of walking, difficulties of speaking, convulsions, and cramping. Few days later, 8 other patients were discovered and hospitalized with same symptoms. On the May 1st, the hospital director reported to that local public health officers to discover of an epidemic of an unknown disease of the central nervous system, which was the official discovery of the Minamata disease. Then, the Minamata Convention on Mercury is globally protect human health and the environment for the adverse effect on mercury. It was named after the Japanese city of Minamata. Uh, then, in Minamata article, then Minamata article number 7, Annex C, Annex C of the convention addressed the issues related with artisanal and small-scale gold mining sector, but mercury usage in gold jewellery manufacturing has not gained much attention under the convention. Therefore, we did this study to gain attention for the mercury usage of the gem and jewellery industry. Then note the introduction. Uh, when we consider the small-scale jewelry manufacturing, small-scale jewelry manufacturers are frequently make 22 karat gold and 20 karat gold jewelries, but upon the request, they also make 18 karat or below jewelry. Not only that, most of them also do jewelry repairing and stone setting when necessary. Uh, we consider the jewelry manufacturing process, they don't use mercury in main manufacturing process. But while making jewelry, tiny gold dust particles are removed and separate all over the workplaces. Uh, and also the goldsmith hands, so that they usually practice collect these dust particles carefully. Uh, Regularly, they wash their hand to separate finger ball and collect the precipitated gold dust particle, and they collect the waste in their workplace also. Then after the few months back, they use the gold separation method to collect those waste gold particles. Uh, this is this is at the gold separation process. First, they collect the gold containing dust particle, then roasting, then cooling and adding nitric acid and heating, then amalgamation using mercury, then burning and get the gold. You can see small video regarding this process. Have you seen this video?
Yes, Nadika, and please remember to click the unmute button on the top of the video so that we can hear the sound. Thank you very much.
According to this video, you can see that the workshop, the jewelry manufacturers are collect the waste in their workshop, then get the powdered gold dust particle, and then they using the charcoal furnace, they roasted that gold dust particles with other contamination particles. When the roasting, the carbon, the particles, paper particles and other carbonic particles are uh, burned and removed from the system, and then cool these roasted plate. Cool this roasted plate using water bath. Then they add the concentrated nitric acid to the roasted particles. The nitric oxide gas were removed, and all the other elements like silver, copper, like that metals are dissolved in this nitric oxide. All the vapor emit to the environment. There is no any separate places. Then as it was removed to the their drainage system directly. You can see the mercury in with a small plastic bag in the open environment. After they add borax to the remaining part, then they use magnet to remove the iron particle in the sample. After that, they added mercury into the precipitated sample and squeezed excess mercury into the bucket. Then amalgamated gold with mercury samples were get, and then that gold amalgamate was roasted using charcoal furnace. All the mercury gas removed from their environment. Not any precautions used to prevent that gas and other chemicals. All the gases were inhaled. Finally, they get 22 karat gold, 24 karat gold in the separation method from the their waste. Therefore, this study was done to, can you hear me? Hello, can you hear me?
Yes, we can hear you. Thank you.
Therefore, this study was done to get more attention regarding the related issues of mercury usage in small-scale jewelry manufacturing. In this project, main objective is to assess the amount of mercury usage in small-scale jewelry industry in order to determine whether the person are at risk for mercury contamination and to introduce non-mercury alternative method for gold extraction. According to achieve above objective, the study was done in 3 phases. Assessing the mercury usage in jewelry manufacturing, a detailed study in Sri Lanka is the phase 1. Then pilot study was done on exposure assessment for mercury in small scale jewellery manufacturing in Sri Lanka through biochemical investigation. Then introducing non-mercury alternative for gold separation in small scale jewellery manufacturing. According to the phase 1, survey on the assessing goldsmith exposure to mercury in small scale jewellery sector. There are two specific objectives: to quantify the mercury usage among the small scale jewellery manufacturers and to sensitize person of the implication of improper use of mercury. When we go the methodology, first we collect the base data and done the staff training to do the proper survey, then questionnaire preparation and validation, field survey and data collection, data interpretation and completion, and complete the phase 1 of the project. Questionnaire consists with 6 major section to get the both quantitative and qualitative information. In that, social economic information, industrial information, gold recovery information and techniques, awareness of mercury toxicity, health status, and mercury storage facility are considered. Then we go to the validation of the questionnaire. First we done pilot study, then get the expert opinion to validity of the study, and then designing the main survey. According to the Gem and Jewellery Authority registered jewellery manufacturers registered, we can find there are 6 districts in Sri Lanka. There is the most of jewellery manufacturers are confined. According to that, Colombo district, Gampaha district, Kandy, Badulla, Galle, Jaffna, Mathura and Hambantota district was done in that questionnaire survey. In that, when we doing the survey, in Colombo district, 75 interviewers are interviewed, and likewise the total number of interviewers are 345. Then we move the social and economic information. Total of individuals 245 individuals were invited. Majority of the person were male, and most of them had education level up to ordinary level or below. Knowledge and training is mainly gained from their generation to generation. When we move to the results and discussion part, when considering the work experience, most of them are they had 10 to 20 years experience, and their age limit is 20 to 50 age limit. Then when we go to the industrial information, there are main 3 kind of workshop were observed: domestic workshop near their houses, separate single workshop near to their house, or separate in their nearby the towns, and separate workshop with other industries, mainly in Colombo district. C Street is the cluster of jewellery manufacturing workshop are there in the with other industries. It was observed that most of the workshop associated with other industries were about 10,650 room with very poor ventilation facility. And 98 of the respondents stated that they work nearly 10 to 12 hours per day. This may reach up to 40 to 50 hours depend on the workload. Majority of the respondents usually work 6 days per week, and they declare that no any child workers involved in this industry. Considering the Mercury storage, 24% of the response is stored mercury in the plastic bag, which can easily get damaged and released into the environment. Approximately 50% of the interviewers refining the gold from the gold with themselves. In others, either sell their waste to other partners to get the service done by the people. An amount of the gold gained by the refining waste varies from one place to other, depend on the amount of work done. Generally, in the moderate work, where 2 or 3 workers work, nearly 5 to 6 pounds of gold can be recovered annually. When considering the chemical usage, following chemicals are also found to be commonly used in the industry: nitric acid, cadmium, copper sulfate, caustic soda, sulfuric acid, hydrochloric acid, sodium alloy, navsaran, phosphorus, potassium nitrate, and potassium cyanide. When we consider the mercury usage, when they used 2 grams of mercury to recover the 4 grams, half of souring for the gold. Cost, when we consider the cost, 1 gram of the mercury cost $0.22 dollars, and therefore the cost for refining 1 pound of the gold is 0.87. According to the goldsmith, they use mercury in gold refining since it is identified as a efficient, effective, and low-cost method. When we consider the awareness on adverse effect on mercury, 20% not aware about the adverse effect, in 70% aware, but they use mercury because it is the easy and cost-effective method. Conclusion of the phase 1, most of the individuals who are engaged in this process are not aware about the harmful effect of mercury. Safe precautions were not practiced when handling the mercury. Mercury can be easily brought from the local market from very low price. Vendors stored mercury in a small plastic container, which can be easily break and contaminate the environment. Most of the response from studied location had some kind of health issue after they engage in the gold refining from waste. Recommendation. Following recommendation are recommended to control mercury usage and assessment. Controlling mercury associated health issues among the employee engaged in the small scale jewelry sector. Assessing the levels of mercury exposure of the considerable population by biomonitoring process. Disseminates knowledge on toxicity of mercury and possible health issues among the consideration population. Reduce the control the mercury usage by introducing efficient and effective alternative techniques on the gold refining. Then we move to the phase 2. Pilot study on exposure assessment of mercury in small-scale jewellery manufacturing in Sri Lanka through biochemical investigation. There are two sub-objectives to assess the mercury levels in small-scale jewellery manufacturers in pilot scale, to identify the viability of detailed biochemical study. The methodology, then prepare the base document, questionnaire validation, ethical clearance, get the ethical clearance, sample collection, informational interviews, sample analysis and mercury exposure assessment, and data analysis and interpretation. First, outline of the questionnaire. Questionnaire consists three major sections: general profile, exposure evaluation, and health profile. Then, using the previous method, we validate our questionnaire. Pilot study was done. Then get the expert opinion to validity of the questionnaire. Then do the survey. Ethical clearance was obtained in University of Peradeniya in Sri Lanka. Then we start informational interviews from the previous survey study. There are three different groups are identified. First one is goldsmith, who make the jewellery gold or silver. Then waste gold separators. They are the clusters go all over the country and collect the waste gold in jewellery workshops, and they collect that waste and separate the gold. Then street cleaners, this cluster mainly in Colombo C Street. Colombo C Street is a largest street with many jewellery manufacturing workshops and the jewellery shops. Therefore, there are so many waste gold dust particle in all over the roads, pavement, and the drainage system. So, this cluster usually every day they collect the dust particle in the street and the pavement and the water drainage system, and and they separate the gold from that waste. General information were collected through the questionnaire. All participants had given written consent to participate with this study and to provide the samples. Then collect the urine sample. Is what urine sample were collected into the sterilized mercury-free polypropylene vessels from 84 individuals. Both case and controls are there. All these samples were kept in cool box during the transportation into the laboratory. Then urine creatinine determination was done in RCD Hospital PLC in Sri Lanka, and then sample preparation for the ICPM and ICP-MS analysis. 2 milliliter of each collected urine sample were transferred into the separate glass tube and then acidified with 0.1 milliliter concentrated nitric acid to reduce the pH. Then 2 milliliter of subsample were digested with the 2 milliliter of nitric, suprapure nitric, and 2 milliliter of H2O2 using microwave digester equipped with a microwave digester. These are the microwave conditions. Then mercury determination was done using inductive coupled plasma mass spectrometry at Industrial Technology Institute in Sri Lanka. Then move on to the results and discussion part. According to the usage and different exposure with mercury, the participants were divided into two different exposure groups: non-exposed control group. Volunteer engaged in the small scale do not use mercury. The number of samples are 34. Exposure group volunteers engaged in small scale jewellery manufacturing and use mercury for gold refining. Number of samples are 50. Medium exposure group goldsmith, a number of samples are 41, and high exposure group base gold separator 9 samples were done. Summary of the statistics of participant in urine Hg level. According to that group, this is the summary of the urine Hg sample level. And toxicology established threshold limit for the when we consider the toxicology established threshold limit for the mercury in urine. According to the human biomonitoring, below the HMB1 is normal. Then HMB1 to HMB2 is alter level. Over the HMB2 is high level. Biological tolerance value and inorganic mercury is workplace limited. Distribution of the mercury concentration in the human urine. The mercury concentration in urine in three exposure groups are compared. These are the values. According to that, high levels of mercury, high exposure group has the high level of mercury in their urine. Distribution of the mercury concentration in the human urine in high exposure subgroups. There are 3% we can samples we can see. There is the levels is very high limit. Out of the 80 participants, 3 were categorized under the alter and high levels of HMB mercury categorization. This is identified as the action level where negative health effects are likely and exposure reduction is essential. Then we consider the health state. These 3 people have the this health state they can these 3 people has the high highest symptoms in that level. Then conclusion and recommendation. The current study results of the urine level of the participant engaged in the jewellery sector emphasize the importance of monitoring industrial exposure level heavy metals by innovative industry. The study results significant that variation in urine mercury level between the various exposure groups. Among the study population, waste gold separator were identified as the subgroup that showed high levels of mercury in their urine sample. They were sorted under high and alter level in HNB categorization, which identified as an action level whether negative health effects are likely and exposure reduction is essential. It is highly recommended extended this study to gain more data on high levels in biological sample, examples of like blood, together with the detailed health assessment. It is essential to introducing strategies to minimize the mercury exposure of this community. Then we did the introducing non-mercury alternative for the gold separation in small-scale jewelry sector. This is the sub-objective to develop and introducing a social acceptable non-mercury alternative method for waste gold separation in small-scale jewelry manufacturing sector. Uh, First, we done the evaluation of the conventional mercury gold separation method. In This is the goal separation method. Then we the gold mercury amalgamation, then heating, and then recover the gold. Uh, Gold separation. This conventional gold separation method. Initial weight of the used gold is 0.95 grams. Recovery weight of the gold is 0.441 grams. So percentage of the separation is 89. This is very efficient method, and we compare the gold separation cost. Cost of separation of 8 grams of gold is $2.07. Why jewelry manufacturers are use this mercury uh, separation method? It is quick, easy, and cost effective. Not need to technical skills person, no need the special laboratory facilities, lack of the awareness on the risk, don't have knowledge to capacity of the alternatives. Then why we find a solution to reduce mercury usage? Then we consider where of finding the solution of reducing mercury usage. First, we consider cost-effective efficiency processing, improve yield, recovery gold with high purity, environmental friendly, no harm to human or animal or environment. So that there are some steps to find the alternatives. Then we identification of convention concerns and identification of potential alternative, evaluate the potential alternatives, development of the most potential alternatives, evaluate of the industrial feasibility and optimizing of the development alternatives, technology transfer and project completion. Alternative gold separation methods. First, we use aquaregia method. Aquaregia preparation using HCl and nitric. Then gold dissolved in this aquaregia. Then adding the reduction agent as sodium metabisulfate. It is not much. It is not much harmful. SMBS is used as the chemical in the food industry also. Then precipitate the gold and heating, then recover the gold. When we consider the efficiency of the gold separation using the aquaregia method, 81.9% efficiency of gold separation cost. When we consider the gold separation cost, 8 grams of gold separation using $1.25. And then we did the hypochlorite method. When the hypochlorite method, grinded gold as particle was dissolved in Clorox solution, and then gold dissolved, adding the SMBS as a reduction agent, then precipitate the gold particles, then gold particles were heat up and recover the gold. In this method, the efficiency is 78.7 percentage. Then gold separation, we consider the cost of the gold separation. Cost of the separation of 8 grams of gold is $2.19. Then Pushkara and Navasaram method, concentration fine waste mixed with Pushkara, when borax and Navasaram, sodium, ammonium chloride and saltpeter, potassium nitrate, and then heated. Major drawbacks of this method, as stated by the interviewers, was that this method is not efficient. According to the result, the efficiency is for 42.5%. When we consider the cost of this separation method, it is $0.74. Conclusion and recommendation of this one. When separation these methods, in mercury methods, mercury gas was emitted. In aquaregia method, nitric gas was emitted, and the hypochlorite method, chlorine gas emitted. In Navasaram, ammonia gas and borax vapor is emitted. When conventional and hypochlorite method, there are so many hazardous mercury gas was emitted in mercury method, but in hypochlorite method, chlorine gas was emitted. But uh, we can reduce the chlorine by discard it into the water. Then conclusion, conventional methods produce the highest separation rate, but cost is very high. More importantly, release mercury gas. Aquaregia can produce better separation rate with very low cost, but environmental unfriendly. Hypochlorite method of extraction of gold is recognized as the best method in terms of environmental friendly, health and cost effective. Therefore, we introduce this hypochlorite method to uh, industry to separate the gold waste. Thank you. This is our findings, and this is our project findings. Thank you for listening.
Richard, can you clarify whether we have time to play the video? Okay. Okay. Any question? I think we had. They have. I was out in the from the room. So this is the time for the for any questions raised by our participants.
We can confirm that there is one question from Mr. Peter Maxon. It says, are you sure about recovery of 5 to 6 pounds of gold in 1 year? Isn't the value of 5 pounds of gold is more than $120,000 US dollars? So this is one question raised by Mr. Peter Maxon. Thank you.
Sorry, can you repeat?
Yes, and if you also stop the sharing of the screen, it will be very obvious. You can see the question in the chat box itself. And also, if Mr. Maxon, you would love to talk with our event organizers, you could also raise your hand. We could also unmute you. But yeah, the question right now is in the chat box. You can see it. Thank you very much.
This pound referring here is not ordinary pound. It is 8 grams. It is called sovereigns, gold sovereigns. 1 pound equal to 8 grams in this gold manufacturing sector. That is the reason. Can you hear us? Hello.
Yes, we can confirm that we can hear you. Thank you.
Yeah, thank you very much. I think Nadika and the team is ready to answer any more questions.
Hi there, I see one hand raised. Could you keep your hand raised so that we can send a request to unmute you? Sorry, I didn't see the name. But if you could raise your hand again, we can unmute you. Thank you.
Hello, everyone.
Hello, we can hear you clearly. Please go ahead.
Yeah, this is Rose Nakauma, working with Planet God Uganda. My question is in regard to the alternatives to mercury-free technology. Can this technology be applied in Uganda? And if yes, how possible is it to get them in Uganda? Because we are implementing the Planet God project in Uganda as impact.
I think Nadika and the team is ready to share whatever the cost figures with you. Actually, in the even in Asian region, this issues common. Not only in Sri Lanka. I mean, we have to study and then the applicability is studied. So if we can further study it little bit, and then we will be able to share the whatever the knowledge they are having with other countries. Yeah. Is it clarify your issue, Miss Rose? Has it clarified your issue? Thank you. Mr. Richard and team, will you kindly clarify whether we have any more time and
Hello, this is Shariful from the Minamata Secretariat. Do you want an extension? I think nobody is posing any more question on the chat panel. Neither one is taking the floor by raising their hands. So if you
so the
have nothing more to add, I think we can end the webinar here.
we don't have anything to add, Mr. Sharif, and thank you very much for your assistance and coordination, and we hope that we can work together with you, and we are ready to share whatever the experience with small scale in this small scale jewelry sector. Thank you very much for all the participants for your participation, and then I'm very sorry for the disturbance happened initial just before the beginning of the this presentation. Thank you very much for you all.
No worries. You are most welcome to come to the COP5. We will meet in person.
Miss Jiva is coming to Kotfai. One of our assistant directors will be participating, and we hope that I will ask from Miss Jiva to come and meet you and then have a chat with you. Thank you.
Thank you so much. Janway, you are muted. Janway, you are muted.
Sorry, thank you everyone, and especially for our event organizers and all the attendees here, and for all the participants. We will highly appreciate it if you could help us to fill up the survey that will pop up once you quit the webinar. And there are still 4 events happening today. You are more than welcome to join them too. Thank you very much. Thank you for your attention.